All right, hello everybody. So I've been getting some emails about this specific question. So I'm just gonna go ahead and just do a video and just post it for everybody to see. That way you can see how this problem's done. All right. So what we're asked here is an experiment can result in one of 5 equally likely simple events: E1, E2, all the way up through E5. Events A, B, and C are defined below. So we have A, which are events E1 and E2, and the probability of getting A is 0.4. Then we have B, which is E2, E3, E4, E5. Probability of that is 0.8. And then we have C, which is E1, E5, and the probability of C equals 0.4. So they're going to ask us to find the following. So I'm just going to go ahead and just kind of move right down the list here. All right. So the best thing to do with this problem is to create what we call a Venn diagram. Now, I've used Venn diagrams in the other videos, so we're going to go ahead and do that. So we're just going to draw like a big box right here. All right, I'm going to put 3 big circles. I'm going to label this one A, this B, and the last one down here is going to be C. And we know the probability of A is going to be 0.4. The probability of B is going to be 0.8. And then the probability of getting C is going to be 0.4. And now I'm going to go ahead and start listing all my events within this Venn diagram. So if you go ahead and you look at events A and C, they have E1 in common. So I'm going to put E1 right here. If we look at sets A and B, they both have E2 in common. So I'm going to go right here and just put in E2. Now, all I got to do is just fill in the rest. So if I look at set B, I have E3, E4 left over because E5 is shared between sets B and C. And that is pretty much how we're going to set this up, okay? And that's going to help us out tremendously when we start answering these questions. So here's our first question. And what I'm going to do is I'm going to do like part A, and then I'm going to erase it, and then do part B, and I'm going to erase it because I always want to have this chart in front of me. So part A, the first thing they're asking for is the complement of A. So the complement of A are going to be all the events that are not in A. So in this case, it's going to be E3, E4, and E5. All right? Now they're asking us to find the probability of the complement. Well, since we have 3 events, okay, events 3, 4, and 5, and each event is 1/5, that gives us 3/5, which is 0.6, okay? And that's how the first one works, all right? Now we're going to do part B. All right, so here's B. B is going to ask for what is the intersection between A and B. Well, the intersection between A and B is only one event, and that is event 2. Oops, sorry, let me write that better. And then the probability of getting only event 2 is going to be 1/5 or 0.2. Okay? So now I'm going to go ahead and, I'm going to do part C. So let me just erase this. So part C is asking for the intersection of B and C. Well, since there's only one event in B and C, that's going to be event 5. Okay. That is also going to be, well, hold on one sec. Sorry, I'm moving too fast. So the probability of B intersection C is going to be 1/5 or 0.2 again. Okay. Now, here's letter D. So let's go ahead. Let me erase this for letter D. So letter D is going to be the union of A or B. So in this case, we're going to write down all of the events that occur in A or B. So in this case, it's going to be E1, E2, E3, E4, and E5. Now, if I were to find the probability of that, I'm going to add all these probabilities up. So that's going to be 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, or 5/5, which equals 1. Okay? Now, let's go ahead and do part E. So, sorry, got to erase again. Nice thing about videos, you can just pause it and go back and see how I did this. So here's E. Now, E is going to be our conditional probability stuff, okay? So when you think of B, given that C has occurred, we got to understand that this is going to be B intersection with C all over C. So when we think about all the events in B intersection C, well, we did that earlier, okay? That is just E5, okay? Now, if we look at just C, this is also going to be E5. So the only event that we have to worry about here is E5, okay? Now we're going to go ahead and we're going to look at how do we actually calculate this, okay? So when I look at the probability of B intersection with C, okay? I have the probability of B I'm sorry, I might have said that backwards. So let me just repeat that. Sorry, it's like 9 o'clock at night and I've been doing math all day. So let's do this again. The probability of B, given that C has occurred, is going to be equal to the probability of B intersection C all over the probability of C. So in this case, if you go back and you look at question C, we did the probability of B and C, and that was 0.2. Okay, now, if you're asking yourself, where did that 0.2 come from? Notice that in the intersection, and I'm going to highlight this for us. Notice that in the intersection of B and C, there's only one element, or one event, and that is E5. So that is a 1 in 5 chance, because you have 5 total events, but you're only selecting one of them. So it's going to be 0.2, okay? Now, for the probability of C, well, the probability of C, and I'm going to highlight that in blue, is all the way down here. It was given to us in the total events, because you got to understand, you have 2 events in C. You have E1 and E5, all right? So the probability of C is going to be 0.4. And when you divide 0.2 divided by 0.4, you're going to get 0.5, all right? Another way to think about that is 2/10, which is really 1/5, 4/10, which is really 2/5. You have a fraction divided by a fraction. So we rewrite the first, division changes the multiplication, and you take the reciprocal of the second. The 5's reduce, you're left over with 1/2. So that's how we get 0.5, okay? So I hope this kind of clarified a lot of stuff, but there's more here. I'm gonna go over more, but I just want you to see how this works, okay? The key to this entire problem is the Venn diagram, which if you watched my previous videos, I hope you did at least, you saw how I did Venn diagrams, all right? So let's see here. I'm going to erase this, and we're going to do letter F. So just give me a second. I'm going to pause the recording. That way I can erase. All right, I'm back. So here's F, and F is A given that B has occurred. So we have to look at A and B, okay? So in this situation, the only event in which we're going to have is E2. That's it, okay? So let's think about how this actually came about. You're looking for, remember, A and B, okay, over B. So when you think about this, A and B is E2. It's right here. I'm circling it right now on the board. All right, it's E2. Now, you have all these other events in E2, E3, and E4, and E5 in B. However, we're only concerned with that E2 because that is the one we're focusing on. By writing B underneath, we're getting rid of all the other ones. All right? So the probability of A, given that B has occurred, is going to equal the probability of A intersection, or B, over the probability of B. So if you go back, and I think it was, if you could, you just want to rewind a video, it's letter B. We did A intersection B, and that is going to be 0.2. You can see it, E2. That's going to be 0.2. Now the probability of B, and I'm going to highlight that in green for us so you can see it, is right here. That's the probability of B. It's 0.8. So let's go ahead and let's divide this by 0.8. So 0.2 divided by 0.8 is going to be 0.25. All right? I hope this is like clarifying some stuff. So now we're going to do we're going to do letter G. So let me erase this. We're going to do G. So give me 1 second. So G is A union B union C. So this is going to be the set of everything. So E1, E2, E3, E4, and E5. And if you think about the probability of all them, well, that's just going to be 1 because it's the entire sample space. So if you were to add them all up, you're going to get 1. Okay? And now the last one is going to be H. So let me go back and let me look at H real quick after I erase. Excuse me. So H is going to be the intersection of A and B and its complement. So when you think about this, the intersection of A and B is only E2. But now we want the complement. So we want everything outside of that. So this is going to be E1, E3, E4, and E5. All right. Now you have 4 events. So the probability of A intersection B's complement is going to be 1/5, 1/5, 1/5, and 1/5, or 4/5, which is 0.8. All right. So that's the first question I wanted to go over. Now the second question here, I'm going to write out, but I think it's going to be the next problem in your homework. At least, I don't know. I'm lying to you. Sorry, because everybody's homework is different, and that's what makes it so hard. That's why I wanted to make a video, just to get it all out of the way. So I'm going to write the next question out, and then we're going to go over it. All right, so here's our next question. So an experiment consists of tossing a single die and observing the number of dots that show on the upper face. So we have events A, B, and C are defined as below. So A is observing number less than 4. B is going to be observing number less than or equal to 2. And C is observing number that is greater than 3. So what I want to do first, before I do anything, okay, is I'm going to go ahead and I'm just going to label what these are. All right, so A is a number less than 4. So A is going to be 1, 2, and 3. Okay, that's going to be A. B is going to be a number less than or equal to the number 2. So that's only 1 and 2. Now C is observe a number greater than 3. So that's going to be 4, 5, and 6. Okay? Now we know if any one of these, the probability is always going to be 1/6. Okay? Because you have a 1 in 6 chance of rolling a 1, or a 1 in 6 chance of rolling a 2, a 1 in 6 chance of rolling a 3, and so forth. Okay? So if you wanted to, P of A here is going to be 3/6. And I'm going to leave it like that, only because I want to make sure all my denominators are going to be the same. Probability of B is going to be 2/6. And then the probability of C is going to be 3/6. Okay? So now, if you guessed correctly, I'm going to draw another Venn diagram. So here's my 3 circles. I'm going to label this A, this B, and this C. I'm going to write everything out. So let's see. In A, we have a 3. And then sets A and B share 1 and 2. And then for C, let's see here. C really doesn't share anything with anything else. So This is all you have right here. There's your Venn diagram. So then the question says, and I want to leave that up there. Oh, wait. I want to label these. Sorry. 3/6, 2/6, and 3/6 again. Okay? So the question says, find the probabilities associated with the following events. Okay? Now, keep it simple. Don't overthink it. Use your Venn diagram. The first one, part A, let me see if I can kind of, that's about as good as I'm going to get right there. So part A says the letter S. And what they're really saying is find the probability of S, which is your total sample space. Well, that's going to be 1. Anytime they ask you for the entire sample space, it's going to be a 1. Okay? Now I'm going to erase because we're going to do part B now. All right, so part B. What is it, part B? Oh, A intersection with B. Okay? So we got to refer back to the previous problem just to think about this. So what I want to do here is I know A, given that B has occurred, is going to be the intersection of A and B, and then the probability formula, the conditional probability formula is over B. However, we're looking right here. You know what? Maybe you didn't see that. Maybe I'm moving too fast. So I'm going to highlight it for us. We're looking right here. All right? So if I want to find the probability of that, the intersection of A and B is going to be 2/6. Okay? Over the probability of B total, which is 2/6. And that's going to equal 1. Okay? Now, we're going to do part C. So part C is asking for find a probability of just selecting B. So the probability of selecting B is going to be 2/6, which reduces down into 1/3. Okay? Now let's go ahead and let's do the letter D. Now D may look a little tricky, but all you got to do is just think about it. So D says find a probability of A intersection B intersection with C. Now, A intersection B intersection with C means this spot right in the middle that I just highlighted in yellow. Because that's the intersection of all 3 sets. Now notice here, there are no elements in there. So, this is going to equal 0. Okay? Now let's go ahead and do E. So I'm going to erase. What is E again? E is A intersection with B. And we're asked to find the probability of that. So the probability of that is going to be 2/6, which equals 1/3. Now we're going to do letter F. Okay, so letter F is A intersection B. Oh, I'm sorry, A intersection C. Sorry about that. So A intersection C is going to be, and I'm just going to go ahead and just shade it in. So A intersection C is right here. There's nothing there. So that's going to equal 0. Okay. Actually, I got to hit Control-Z twice so I can get rid of that. There we go. That looks so much better now. A intersection C is 0. Now, what's the next one? G. G is going to be, let's see, B intersection with C. Okay? So B intersection with C is right here. All right? Notice there's nothing there. So that's just going to be equal to 0. All right? Now we're going to have letter H. And letter H is A union C. So the probability of A union C, well, that's going to be the entire circle of A and the entire circle of C. But if you look at that, that's all of the events, possible events that you can have. 1, 2, 3, 4, 5, and 6. So that's going to be 1 because it's the entire thing. Okay? And then the last question here is going to be question I. So give me a second. Let me write out question I here. I is going to be the probability of B union C. Now, the probability of B union C are going to be events 1, 2, 4, 5, and 6. All right? So this is going to be 1, 6. Actually, let me write out the events first. So B union C, the events are 1, 2, 4, 5, and 6. So if you look at this, you have a total number of outcomes, which are going to be 5 over the total sample space, which is just 6. Okay? And that is it for these two problems. So anytime we are giving you outcomes and sets, use a Venn diagram and just write it out. I hope this helps. And I will talk to you, I guess, if you have any more questions. See ya. Bye.